All right. Welcome, everybody. We're about to begin in a couple of minutes, starting off a little bit early. Letting everybody connect in and just give us about 60 seconds and we'll get going. All right, welcome everybody. Thanks for joining us today. Good afternoon for those in the East Coast. Good morning to those on the West Coast. And welcome everybody for anybody that's around the world there. So we're in the next installment of our DevOps webinars. We began speaking about kind of just Azure DevOps in a nutshell earlier this summer. And we've been doing other webinars regarding kind of DevOps in general. This one is probably the most, in my opinion, the most kind of neat, cool, if you will, with regard to putting together a tool chain of, in this case, non-Microsoft tools. What we're bringing you today is using Azure DevOps to orchestrate a tool chain, a pipeline that brings together non-Microsoft tools and some of the more popular ones as well. So my name is Gerard McGann. I am the Senior Director of Solution Delivery. I'm also the practice lead for our DevOps practice here at Tallan. And I am accompanied by my peer, Ben Thompson, who's our resident cloud architect and DevOps engineer, who will also be joining me for the technical part of the demonstration. So I just want to jump into some of the some information around like a lot of these tools. And that's where we're going to really start and talk about this. Is that, reason why we're doing this and kind of putting together if you will, it's really, to be honest, is a summary of a pipeline. Is there's so many tools out there from a DevOps perspective. There's about 120 plus tools that you could choose from in order to put together an effective pipeline. And believe it or not, out of those 120 plus tools, only about 33% are really known. And what known really means that, it's either they've been, they've been marketed really well, or the developer community has really taken to them. And obviously through word of mouth, it's being advertised as being a really good tool. And so then a lot of these organizations and developer groups gravitate to them and use them. And with that said, what does that mean? Well, out of all the tools that are available, there's about 2 or 3 that are in any given category are actually used as a most common tool set. And what you're seeing here is the DevOps periodic table. And this has been put together by Zebio Labs a while back. And Zebio Labs is a company that's a DevOps company where, one of their most popular tools is, believe it or not, value stream tracking. And they put together this periodic table to kind of illustrate the amount of tools that are out there. And believe it or not all the tools are actually here. Like you're not going to see things like Azure Boards. And just because it's not up to date yet. And I think they're going to release a new one this year, and it's going to include some of those other services that, maybe you're using today that may not be on here. But you'll see that they break it down into particular categories, in the sense of things we're already familiar with, things like source control and configuration management and testing and monitoring and operations, very much related to DevOps practices. But they break it down to smaller chunks, which kind of helps consume this a little bit better. And what's really neat about this is an interactive periodic table. I highly recommend that you go to this website because it's an interactive tool that will help you understand, if you're going to put together a pipeline or a tool chain, more so the tool chain, not so much the pipeline, the tool chain, it'll actually give you a diagram, a visual diagram of all the tools that you chose and where they apply into the DevOps process. To make sure that you're really making, you're making sure you're closing those gaps on the areas that maybe you're looking to narrow down and introduce a tool they maybe don't yet using today. So again, I highly recommend going out there, taking a look at it. It's a really neat tool. So, with that said, today we're going to be putting together a tool chain that is using Azure DevOps to orchestrate the pipeline. So while DevOps is a bigger process, it talks about, the 8 phases. We have planning and tracking, the coding, build and test, release and deploy, operations and monitor. In this case, I included environment. We're only going to be really talking about the coding and the building and testing today, as well as the deploy environment. And so, we're going to be talking about very specifically, how do we incorporate GitHub into Azure DevOps? We know, if you're familiar with Azure DevOps, you know that there's a built-in repository. You can choose Team Foundation version control or Git as a repository. But I don't know if you realize, but Microsoft is pushing kind of hard now that as part of your tool chain, you should be using GitHub. And that's because Microsoft bought GitHub a couple of years back, and now they're really starting to enhance it. They're actually building certain functionality that are very akin to what Azure DevOps can do today, especially around the pipelines. They're called GitHub Actions. Very similar to how you put together tasks and trigger off continuous integration. These actions do the same thing. And so, we're going to incorporate GitHub into Azure DevOps as part of the tool chain. And they're also going to be using some other aspects part of the build. We're actually going to use JUnit because we're going to be using a Java application here. It's not going to be .NET. And then we're also going to be incorporating SonarQube, which is a very popular, one of those common 33% that I was talking about, one of those common tools that are used to do static code analysis, detect vulnerabilities in the code before it even hits the environment, and be able to report back to the team that, listen, this code that you wrote here, there's some issues with it and they got to be fixed. So, Ben's going to be showing that and show you how that works and how you incorporate into the pipeline. We're going to be using JUnit for unit tests, right? Because it is going to be a Java application. And what we're going to do is we're going to deploy. We're going to do infrastructure as code using Terraform. So because we're going to be doing a multi-cloud deployment under one pipeline, just one pipeline is going to deploy to AWS and Azure at the same time, we need an agnostic infrastructure as code tool, and that's Terraform. Terraform is a very popular but yet powerful tool that you can use to write it essentially once and be able to deploy to multiple platforms. In this case, like I said, AWS and Azure. So we can't just use the ARM templates that are out of the box that Azure's used to and knows. And of course, Azure DevOps obviously is very familiar with that, as you can incorporate with your pipeline. But we need to bring in a third party here. So that's what Terraform is all about. And then what we're going to do is, like I said, we're going to deploy to AWS and Microsoft Azure. It is going to be a web application. So we're going to be using, in this case, Elastic Beanstalk for AWS, and then we're going to be using App Services for Microsoft Azure. And Ben will walk you through how that's all set up. So for this particular webinar, that's what we're going to be focusing on. Some of the other ones, we're going to cover in a later webinar right now. But from here, this is what we're going to be talking about. So we're going to jump right into the demonstration at this point. So Ben, I'll let you take it away from here, and hopefully, I want everybody to enjoy what you put together.
Thanks for the introduction, Gerard. Like Gerard said, I'm an Azure and DevOps architect here at Tallan. So I work a lot in the Azure DevOps, in the Azure DevOps area. So in our typically when you think DevOps, you think, oh, there's the boards, there's the repos, there's pipelines, there's test plans all in there. But it is actually very, very much modular. So you can choose which parts you want. Sorry, I'm just sharing my screen. you can choose which parts you want to use. So you should see momentarily my DevOps project that I'm going to be using for this example. And on the left-hand side, we do have the overview, which gives us the wiki. It gives us our dashboard. We have boards where we can track work items. We have pipelines to actually build our code and deploy it. We have test plans if we want to run through some test cases. We have artifacts to store custom NuGet or NPM packages. But what's missing that you would normally see here is the repos. And that's because in the project settings, I came in and I turned repos off because we're not going to use the DevOps repos. We're going to use the GitHub as the repository for our code. And when you use GitHub, you can use a public project. So you'll see most of the time you go to GitHub, you're looking for open source projects. So those are all public. Anyone can see them. You can pull that into your own pipeline if you wanted to build it. The other option is to use a private repository in GitHub, which GitHub now supports for all users. I think that was in the past couple of years they started really pushing that. So your GitHub repository, you can host your code there and have it you can have it limited to people in your organization. So we'll take a look at GitHub, and I have my own user account here, and I've created this BYOToolchain repository, and as you can see here, it's private, so it's limited to, at this moment, only myself, or I could add other people to this as well, people on my project team. As a sample for this webinar, I'm using the Spring Pet Clinic sample application. This is a Java Spring application that I found on GitHub, and it's basically a vet's office, software you might use for a vet's office to schedule appointments. On top of that, I've made a couple changes, but I just want to go over what we have to start with. So we have all of the Java Spring infrastructure here to build the application and run it, and that's using Maven to run the build. It includes some unit tests that will be running as part of our build pipeline to make sure that all of our application code passes those unit tests before we go and send it off to our different environments. And on top of what's already been provided by this open source project, I've added in an infrastructure section where I keep my Terraform files. And that's what we're going to use to stand up our environments in Azure and AWS. And I'll go into those in a little more detail later. The final addition to this repository is the actual Azure pipeline. So the pipeline, we'll see the contents of that later, but I've chosen to use the YAML multi-stage pipelines that DevOps offers, and that lets you put the build and the release in the same YAML file and run it as one continuous unit with multiple stages. The other option for DevOps pipelines is to use a graphical model where you kind of drag and drop different tasks on there. But Microsoft is really moving towards this YAML model so that you can put your pipeline in your repository like I've done here. So back to DevOps. So we saw, we don't have the repos in there, but we do still have to make DevOps aware of our GitHub. And to do that, we create what's called a service connection. So I actually have 4 service connections here. The first one here is for GitHub, and that's giving DevOps permission to take a look at my private GitHub repository and build code off of it. I also have an AWS service connection. I use that for the deployment of the code to Elastic Beanstalk. I have an Azure subscription service connection, and that's the same to deploy the code out to the app service running in Azure. And by the way, both of these are also used for the Terraform deployments. We use these same credentials. And then I have one for SonarQube so that DevOps can send the source code over to SonarQube and get a readback of, is this code good quality according to the quality metrics we have set up? Are there any vulnerabilities? And we'll take a look at that too. All right, so the first thing that I want to take a look at in DevOps is the pipeline. And actually, I will look at the file over here. So the DevOps pipeline starts off, it's a YAML file. It follows regular YAML syntax. There are certain conventions, such as the trigger and PR. So these everything in here means certain things, of course. So the trigger means that whenever we have a new version of code on the master branch, this pipeline is going to automatically be run by DevOps. And even though our code's in GitHub, DevOps can still pick up on the new code changes being made. The second one is PR. So this means that whenever we have a new PR, a new pull request submitted in DevOps, or I'm sorry, in GitHub, DevOps is going to build that as long as it's against the master branch. If you're not familiar with pull requests, it's basically a Git workflow tool to merge code from a feature branch that a developer is working on back into the master branch or the trunk branch, so that it's integrated back into the main repository. And pull requests a lot of times come along with code reviews and ensuring that your automated tests run and that your build is successful before you can merge that back into the master branch. So that's what we're using this PR build for here.
Hi, Ben. Can you zoom in on your screen a
Oh,
little bit? We're getting some
sorry.
reports that it's a little small.
Yeah, it's quite small. All right, that should be better. The next part of this file is looking at what pool we're going to run this on. So in our case, we're just going to run this on one of Microsoft's hosted build agents. So DevOps does provide build agents for you to use that you don't have to maintain yourself. By default and for free, you get 1,800 minutes of these build agents time every month, or you can pay a certain fee to have unlimited use of one or more build agents. So that's what I'm doing here. I'm using a Linux build agent to actually run this pipeline. We can also define some variables. And you'll notice that we are actually referencing a variable here. This storage keys and things like that, we want to keep out of our source code repository. So DevOps has a variables storage for secret variables. So that's where this is coming from. And from there, I'm not going to go through every single step in here, but in the build stage, what we're going to do is we're going to set SonarQube up. So that's basically going to make sure that we can connect to the SonarQube server and send information over. We're going to use Maven to actually run our build and run our unit tests. So the only thing we have to do to enable the unit test is publish JUnit results, and then the Maven takes care of the rest based on the configuration in the project. We publish the code coverage results, and we'll take a look at those too once we do a build, and that'll show us which parts of our code have and have not been covered by the unit tests. We want to publish our output jar file as a product of this stage of the build. That way, later on in other stages, we can get to this file. I also publish the infrastructure folder so that we have those Terraform files to deploy out to each environment. And then finally, this part here, SonarQube publish, this will have the build wait until SonarQube finishes its analysis, and then it includes that analysis as part of the DevOps pipeline run. So it gets all that information in one place. Once the build is done, we move on to the dev deploy, the deploy out to the dev environment. We have two jobs here. We have one for Azure and one for AWS. They don't depend on each other, so DevOps can run them in whatever order it wants, or if we have more than one build agent available, it's going to run them in parallel. So for the Azure deployment, we take that Terraform file, we inject some variables into it so that we can get to the remote store for the environment state. We install Terraform on the build agent, and then we run these three commands to initialize Terraform, download any dependencies, and then apply the changes from our Terraform file to the Azure environment. And then once the environment's been deployed, we use the Azure Resource Manager web app deployment task to deploy that jar file out to our app service running in Azure. And we do something similar for AWS. So we put some variables into our AWS Terraform file. We install Terraform because this could be running on a different build agent than the job up here. So we just need to cover our bases. We run the same steps for Terraform that we do in Azure. And this is where Gerard was talking about Terraform being good for multi-cloud. It is cloud agnostic, so you run the same commands, whether it's Azure, AWS, GCP, and it's the same language to write these Terraform files. The only difference is, on Azure, you create Azure resources. On AWS, you create AWS resources. So once our environment's all set up for AWS, we just need to deploy our application. So AWS, it's 2 steps. The first step is to actually get our jar file up to our S3 bucket that we have for our application deployments. And then we just need to run this beanstalk deploy application task to take that uploaded jar file and create a new version of the application and apply that to our environment. So that's about it for the Azure pipeline. So that's what it's actually going through to integrate all these different things together. The next thing that we're going to look at is the SonarQube integration. So when you send your project over to SonarQube, SonarQube is going to scan through the code, and it looks for several key areas. It looks for bugs. So that's obviously it's not going to find anything, but if you have a possible null reference bug, it's going to find that. The general things that a linter might find is what SonarQube is going to find. It can find vulnerabilities. So this could be something like a SQL injection vulnerability that you might not find just looking at it, but it can run its algorithms to figure out if you have one of those. Hotspots reviewed, I believe that is more of a right. So that's more for manual review of certain very sensitive areas. This project doesn't really have anything in that area. And then it also measures tech debt, code smells, and that falls under maintainability. And then it's also showing, we have 39 unit tests and about 90% code coverage. And it also shows any duplicated code that's in your project. And the neat thing about SonarQube is that it doesn't just scan your code, as you're sending it in. It keeps a history of, what's changing in your code over time. So you can look at this and say, okay, well, a month ago we had, 100 bugs, and now we only have 90 bugs, or our vulnerabilities rating went from D to B. And, as you fix things, you see this start to improve. And the other nice thing about this is it's fix the leak mentality. So if you already have a project established, you might run SonarQube on it and you might find, oh, hey, we have 9 vulnerabilities. Well, that doesn't mean that you need to stop everything right where you are and rush to fix these vulnerabilities. That's not realistic. So all that SonarQube asks is that when you introduce new code, you don't introduce any new vulnerabilities. So if I submit a new version of this code, and this one here, I think I just changed something small, I didn't introduce new vulnerabilities, so I get a score of A for my new code. I still have that D rating because I have 9 vulnerabilities overall. But if I set up a quality gate saying that new code needs to have no new vulnerabilities, it can't have, code coverage shouldn't decrease, and stuff like that, which we can figure up here, you can make sure that your project's quality over time never decreases, it only increases. And then over time, you can work on fixing your vulnerabilities and fixing your bugs, but you don't need to start on it right away. And that's one of the very nice things about how SonarQube does this scanning. As far as setting up quality gates, you can come in here. There's the default SonarQube way. And that just has a base set of metrics for new code. But you can also come in and say that, okay, well, I want duplicated lines to be less than 5%, whereas the default has less than 3%. So you can come in and tailor this to your organization to make sure that whatever standards you have are reflected inside SonarQube. And I mean, on top of this, you can define custom rules. You can look at issues on your projects. And this is just one project in here. You can have SonarQube and run a whole bunch of different projects in it in different languages. There's a large number of languages that SonarQube supports. And this version that I have here is the community edition. So that's the free version. Even as an organization, you're welcome to use this version, but it does have restrictions, whereas there are paid tiers that introduce more languages you can scan, and introduce other nice to have features like looking at branches. So the community edition won't look at your feature branches to scan them. It'll only ever look at your main branch. So, I mean, that's obviously how they get you in the door, is providing a lot of the functionality in the base version. And then for larger teams, you'll want to look at the paid versions to get more out of it. All right, so that's SonarQube. We'll see, sending data to that when we actually run our pipeline. So coming back to the build, so the Java, we'll see that getting built. The next thing I want to look at though is Terraform. So to do that, I'm going to come back to our Terraform files. So Terraform basically, it's a YAML, so it's sort of like YAML. It's a custom language called HCL, named after the company who created Terraform. And you can, like I was saying earlier, you use that same language to write configurations for multiple clouds. So the first thing that we're going to do is set up our providers in your file. So this file is the Azure one. So I'm setting up my Azure provider. The next part here, backend, this is where we set, like I said before, Terraform keeps state between times that you run it. So if you just run it locally, it's going to store that state on your local machine, but that doesn't really help DevOps. So we need a local or a remote place to store it. The company that makes Terraform offers a cloud storage of their own. So you can hook into that if you want to. Here, all I've done is created an Azure storage account that I use as the remote store for both the Azure and the AWS Terraform files. And that basically lets you see when you get to the apply stage, did someone else go in and change the Azure or AWS environment outside of Terraform? Because you don't, and it'll kind of give you that warning because you don't want to bring the system into an inconsistent state by making changes on something that isn't what you thought it was. So that's really one of the points of having that remote store stay consistent across different pipeline runs. So that's what we use that for. After that, all we do is we set some variables. We define our resources that we want to create. So in this case, we want the app service plan. We're going to run that on the premium tier. And we want the actual app service itself. So we want that running Java. You can define any configuration value that you can do in the Azure portal or the AWS console. You can put it in here. We can create a MySQL database if we want to do data storage. And the AWS file is very similar to this one. You'll see it's the exact same language, exact same syntax. The only different is now we use the AWS provider instead of the Azure one. And we obviously are creating different types of resources. So we're creating the Elastic Beanstalk application and environment instead of the app service on Azure. But other than that, and various differences in how you configure each service, it's the same syntax on each one. All right, so now that we've looked at the different pieces of this, let's actually go and look at what it looks like when we want to make a change. So to make that change, first I'm going to pull down the code to my local computer. All right, so I'm going to clone my repository. Then let me open it up in VS Code. All right, so I'm going to follow a Git workflow here. So I'm going to, once it realizes that it's connected to a Git repository, I'm going to create a new branch and make my changes on that branch. All right, so we'll call it features / new version. Very descriptive. So now that we're on this new version branch, I can make whatever changes I want. I can commit, I can push up to GitHub, and the other developers on the project can work unaffected by whatever I'm doing. I'm not going to do anything crazy. I'm going to go into the project files here, and I'm just going to, on the welcome page, so I just had that message here. I'll just say welcome to BYOToolchain. All right, so now that I have my change, I'm going to do my commit, message, stage changes, commit it, and then I'll push my changes back up to GitHub. We have to create the new upstream branch because we haven't created it in GitHub, just locally. Looks like it's done now. So when we get back into GitHub, I'll just refresh this. We can look now, we have this new version, or this new branch here for the new version code. So now I have this option to compare and pull request. So this will let us go through the PR workflow inside of GitHub. So it pre-populates everything. So really all I have to do is do create pull request. I haven't actually created a policy on the master branch to enforce pull requests. If I did, I would have to add a person in here, such as Gerard, to come in and actually approve my code. In this case, we see, okay, the branch has no conflict, so it does merge conflict automatically. And now I see something here. So it actually is running the build in DevOps, and that comes through to GitHub. So GitHub is aware that this build is running, and it's telling me, you better wait because some checks haven't completed yet. So at this point, let's take a look at DevOps and see what's going on. All right, so I do see my new build running, and we see it running for pull request 1. So that's the first pull request I've done on this repository, number 1. It traces it back to the user that created it, and it's telling us which commit version it's on, and now we can see it actually starting to go through the build stage. One thing that I did not mention before, let me open it up in a new tab, is that when we're running our pull request build, we don't want it to deploy out to our dev environment. We want to wait until the pull request is approved, and then we'll do that dev deployment. So to enforce that, what we do is the dev stage has this condition on it. So it's only going to run if the previous stage succeeded, so that's the build, and the reason for the build is not equal to pull request. So this is how, even though it's a multi-stage pipeline, everything's in this one file, this is how we keep it from deploying to our dev environment when we're just doing a test build for the pull request. So back in DevOps, we can take a look at what we get out of this build. So first, it's going to just check out the code from GitHub. So that's getting the code onto the Azure DevOps build agent. If you have a large project, whether it's in GitHub or Azure repos, you can consider using a self-hosted build agent, because when you use the Microsoft hosted build agent, you get a new version every time, a new VM basically running your code. So it has to do a full checkout. If you have your own build agent, it can do basically the partial checkout. So it can keep the code around and just pull the new changes. So if you have a large repository, that can help speed things up. We're actually skipping the SonarQube steps here because, like I said, I'm running the community edition of SonarQube, and you have to be on one of the paid editions in order to have it analyze your feature branches. But we'll do the full SonarQube when we actually do the do the main build that we're going to deploy. My recommendation here is honestly, if you have the ability to pay and get the paid version of SonarQube, definitely integrate it with your pull requests, because it'll put its feedback in here as well. You can configure that. The next thing it does is it runs through the Maven build. It publishes code coverage, and then it's publishing our artifacts, and it succeeded. So what we can look at here is our tests. Our test passed. If they didn't pass, then this build would have failed. You can come in here and see, all the test cases that we ran. If it did fail, you get error information about why it failed. Obviously, it didn't fail, so we don't have that information. You also get the code coverage. So we're using Jacoco to generate this report. And it basically tells us, so out of all of our classes, all of our files, we have 222 lines that are covered and only 16 that are uncovered. So we have about 93% coverage as far as lines go. Branches, we're only up to 75%. So code coverage, basically you can come in here and see, okay, well, my unit tests hit this part. They did not hit this part. Let me see if there's any of these that are better. All right, so welcome controller. So our unit test code, no, that's also not a good one. Well, yeah, I guess you get the idea. I had a good one, and I didn't write it down, so that's my mistake. Here, this one should be good. So this owner class, we hit all of these properties up here, but what we don't hit is this get pet name or get pet method. And in this method down here, we don't hit this block of code. So this is really what you want to look at your code coverage for, especially if you have a lot of branching. Code coverage will tell you if you hit if else statement, did you hit the if but not the else. So that's one of the main benefits of code coverage, is to make sure that your unit tests are encompassing everything, or at least as much of it as possible. All right, now back on GitHub, we see that our build succeeded. So let's go ahead and merge that pull request. All right, so it says my changes are in master. If I come back to code, I'm back on the master branch, and I see my new welcome message commit is in here. So when I actually go back to DevOps, I'll see that running. I just want to show one more thing, which is that we ran the build, and it did not run the dev deploy. And that's what you want from your pull requests. You want to make sure that your automated tests run. You want to make sure your build is successful against the code, but you don't really want to deploy it out to your environment. In general, there's cases where you can where you might want to do that. If you want to run like a UI test or something, you might want to deploy it out to a temporary environment. But now that we merged into master, we can take a look at the actual pipeline deploy, or at the actual pipeline run for the code on the master branch. And this also was triggered automatically based on our trigger at the top of the YAML file. So it's going to run through the same steps that it ran through before. So basically just redo the build against what's actually in master now. So we don't have to look too far into that, but while that's running, I'm going to go back to that last build because I also wanted to show that that as you can get the output from your build. So when we did that publish, those show up right here. So I can actually come in here, and if I wanted to, I can download my Terraform file that was a part of this build, or I can download the jar file that was the result of this build. And you can configure how long DevOps is going to keep your builds around for. So you can go back in time and see, if you need to do a rollback, you can come back here and get the artifacts to do a rollback, or whatever you want to use that for. It's in here. All right, so over here, we're just running our build again. It should be done in a minute, and then it'll hop right down to this dev stage. You might not always want to do your deployments right away. You might want to wait for them, whether it's automatic or some manual process. And in that case, what you do is you define an environment that's associated with the deployment stage. And in the environment, you can actually come in here and do approvals and checks. And there's a bunch of options in here for different things you can do. If you do approvals, that means that one or more people have to come in here and click approve before it'll start this dev stage. You can do branch control. So you can say, I only want master going to dev, or I only want a release branch going to production. You can ensure that the deployment gets started during certain business hour or a certain time window. So maybe you only want deployments to production to happen after 8 p.m. You can set that here. There's a bunch of other options down here. Like if you want to run an Azure function, if you want to hit a REST API, if you want to run an Azure monitor query to make sure that there's no alerts before you do your deployment. So there's a bunch of options in here that you can configure if you want to customize how your different environments and different deployments work. So now that the build is done, we actually have some more information on this one because we sent it over to SonarQube. So we see our quality gate passed, and that's based on what we define up here under quality gates. So since it passed all of these metrics, it's considered a pass, even though we still have those 9 vulnerabilities in the code. So that's kind of what I was saying about fix the leak. We want to we don't want to penalize new code that's being written for the sins of past code. We really just want to make sure that going forward, everything nothing gets worse. We want to increase quality when we can and move forward without decreasing quality in other cases. All right, so now that we're doing our dev deployment, we'll actually watch this. So this time, like I said before, Azure can really run either of these jobs in parallel or in whatever order it wants because there's no dependency between them. In this case, it chose to run AWS first. So we're doing our token replacement. We install Terraform. We run this PowerShell command to deploy out the environment. We upload our new package to S3. And then we actually deploy the application using that file that we uploaded to S3. So Azure's going to run now. While we wait for Azure, we can actually take a look at what is going on in AWS. So in AWS, we have this Elastic Beanstalk application and a corresponding environment. So when I look at the application, it was last modified today at 12:40, which corresponds to the time that we ran our pipeline. If I look at the environment, so it's running Java on Linux. Health is okay. We have this version running, which is the one that we uploaded. It's just named automatically because I didn't provide an explicit name to it. And I can come in here and actually click on this, and when this loads up, here's our website. And we have our new text that we typed into the welcome page here. So that was the process of deploying from Azure DevOps to AWS. And now I'm realizing that I probably should have done Azure first because that's the standard one. The AWS is the non-standard integration, so it's a little more exciting. But it isn't really any more difficult to use Azure DevOps with AWS than it is with Azure. If we go back to the pipeline file, which I can actually open in here too. If we go back to this pipeline file, I don't have much more code in here compared to what I have for the Azure side. So the Azure side is here. So for Azure side, we deploy out the Terraform resources, and then we deploy the environment. For AWS, we do pretty much the same thing. We do Terraform. The only additional step, I guess, is the separate upload of the application. But the actual integration between DevOps and AWS, it isn't difficult. It's fully supported. All you have to do is, if you search for Azure DevOps AWS, I think it's called a plugin, you'll get this AWS toolkit for Azure DevOps. And it's just a plugin for whether you have the DevOps service that's hosted by Microsoft in Azure, or you have an on-premises Azure DevOps Server 2019, the new version of TFS. All you have to do is come in here and add this, this package from Amazon to your DevOps installation. And this gives you all of the tools that you need to do deployments to AWS. Now my Azure's finished running as well. So we also do the Terraform and we do our deployment here. So I have Azure up. Let's see. So we have our resource group that was created with Terraform, and we have the actual website. So, and when I browse here, I also see the same site. So we have it running on the, hold on, finding my window. So we have it running on the left side on AWS and on the right side on Azure. So at this point, you have different things that you can do here. If you want to do a multi-cloud deployment, DevOps can definitely do that. It can deploy out to Azure and AWS, the same application. You could host these in an active passive. Maybe Azure's your main, and if you want to make sure, if there's problems with Azure, you can switch everyone over to running on AWS. There's also no reason why you can't run both at the same time and distribute different sets of users to each one. And Azure DevOps is the tool that you can use to do your integrations from your code, wherever it's hosted, GitHub, GitLab, DevOps itself, and on-premises Git server, TFS. DevOps can pull in your code, run your builds, and then deploy it out to these two different environments. All right, so we're almost at the end of this webinar now. We actually have one final poll that we want to hear from everyone based on what you saw today. So I'm going to let Gerard walk you through that.
Thanks, Ben. So great job on the demonstration. And I hope everybody kind of learned a little something there, especially using non-Microsoft tools here. As you can tell that we really went all into it using a Java application and deploying it to two different clouds. In this case, the direct competitor of Azure, which is AWS. But you guys, as Ben mentioned, one thing that Azure DevOps does really well is it lets you bring in your own tools, and you can orchestrate that accordingly as you saw. It makes it a very, very powerful DevOps tool that you can use at your disposal. So again, that does conclude our webinar. So thanks for listening. I just want to let everybody know later this fall, we're going to have another webinar in our installment here for DevOps. And we're going to be talking about value stream tracking. As some of you are probably going through a DevOps transformation or some, journey into, maybe evaluating or incorporating DevOps processes. Organizations are looking for ways to ensure that these changes that they're making actually adds value to the organization. And that's what this webinar is about, and how to effectively kind of track those processes and get the most out of them. So we hope you connect in and join us on the next webinar this fall. So look for the invite. And again, thanks for listening.